What is up, guys? I'm going to talk about something called PCA, which is Principal Component Analysis. Now, what PCA is it is a way to reduce the dimensions in a data set. A lot of times we'll get data sets where there are hundreds, even thousands, even hundreds of thousands of features. And this can be really time consuming for the computer. And it can make the models take a really long time, a lot longer than necessary. And there's actually a way with PCA, Principal Component Analysis, to retain all the information from that data with fewer features. So here's just a little breakdown of how that actually works. Now you can implement PCA without having any understanding of how it works, but this is just, it's better to understand how it works than not to, of course. So in this first example, as you see over here, we've got the slope. It looks like we've got a slope of around 2 if you look at it. I mean, I just kind of drew this, but it looks like we're going up 2 over 1, up 2 over 1. So a slope of 2 and then an intercept of 0. And what's going to happen is we can notice that there's, it follows a slope. These data points, these features mapped onto each other follow a slope. Okay. Now, what we notice is because they all follow the slope, we can actually collapse this and make this 2-dimensional space a single dimension. What I mean by that is now we'll just have these 5 blue data points right here, and we'll draw a line, and now we've just turned it into a number line. And now this was a pretty clean, pretty perfect example. A lot of times you may get data that looks a little more like this, where there's a bit more variety. What we do in a situation like this is we kind of identify the algorithm, PCA algorithm will identify a line that best splits the data. I know that line probably isn't it. It's kind of a sloppy line, but that's just my handwriting. Anyway, and then what happens is all these data points will get drawn to the center. They'll get drawn onto that number line, and the same thing will happen. We'll turn a 2-dimensional data space, or I'm sorry, a 2-dimensional space into a single dimension, turning 2 dimensions into 1 dimensions. Now if we did this throughout the data set, we could eventually, for example, we'll just turn something like 20,000 features into maybe only 10,000 features, and then we could scale it down even further and turn it into only like 5,000 features. That would be an example of how PCA might be used. Now let me show you a notebook. I'll take you in the notebook. I'll show you a little bit of the code here, and I'll also leave the documentation in the description as well. So let's take a look over here. And where's the code? Okay. So the way you import this, the import statement right here from sklearn.decomposition import PCA. And here I'm going to show you the other. So this is how we actually set up the PCA. And the PCA is something that will be done on the training and the testing data, because the training data and the testing data need to have the same number of features. So if we did the training data, reduced it down to like half the features, then there would be an error when you do the testing because it wouldn't have the right number of features. But anyway, what we do is we actually, before we do that, I'm sorry, skip the step. You need to instantiate PCA. So a lot of these machine learning models and all these things, they often are classes that have to get instantiated. So right here is where we pass, let me annotate this. So then what else happens is we pass in n components. So n components, that's how many components we want to reduce it down to. right here, as you see, we passed in 125 components. And now we have down here, all this other stuff. So yeah, we set the components and then we fit it on the data, and we only give it X. We only give it X because we're not doing this to the labels, we're only doing this to the data, right? And now lastly, we have the X train, X test right here. So we transform it. So we do fit up here, and then we do transform over here. And when you transform it, that's when the so when you do the fitting, the model or the algorithm gets let's say the code, the computer, it gets ready to perform PCA. But now when you do this transform, it actually makes it transforms the data. So it actually does the PCA transformation. And now I'll show you just a little more on the context of this use case here. So in this use case, we have faces of pictures of world politicians, world leaders, and we're classifying them. So each image, each pixel value on this image is its own feature. So that means that there are a lot of features. I think it was like 2,000 originally features in the data set, because every single pixel value has its own feature. So we've reduced that down to 125 features. So that way the algorithm can actually process it and make predictions and train and all of that in a reasonable amount of time. So anyway, that's been the video. I hope you enjoyed it. And I will be making more in the future. So leave a like, comment, subscribe.